So we're going to do a few examples of stating the zeros for the quadratic relationships. We're going to use the equation version. So again, anytime that you're given a quadratic relationship, it has to be in factored form. And so most of these are in either factored form or they're in standard form. And we've already talked about how to convert into standard form from vertex form. So those are some skills that we'll continue to build on even as we get into the next lesson. So what we're going to start off with here is we want to state the zeros for this particular equation. So we'll look at the upper left here. So in this particular question, we've got y is equal to x minus 7 times x plus 8. So again, the zeros are the opposite value of the number that's here. So here we've got negative 7. So the zeros are actually going to be positive 7 and negative 8. Okay, so again, you'll notice that I've used the word and, not or, because both of those numbers are zeros. Okay, so they apply to both pieces. In the example here on the right, again, we have two zeros. So in this case, our zeros are going to be positive 2 and positive 8. Okay, so we have two sets of zeros in that particular example. If we look toward the next set, here we have y is equal to x squared minus 8x plus 12. This is written in standard form. So first thing that we need to do is actually convert from standard form into factored form. In order to do that, we need to use our factoring. So we need to find two numbers that are multiply to positive 12 and add to negative 8. So we know that those two numbers have to be both negative. So if I look at 1 and negative, sorry, 1 and positive 12, they would add to positive 13. 2 and 6 would multiply to positive 12, but that would give me positive 8. I need them to add to negative 8. So in this case, I'm going to flip the sign. Negative 2 times negative 6 also gives me positive 12, but when I add them, it gives me negative 8. So in this case, the factored form is going to be x minus 2 times x minus 6. And so therefore the zeros are going to be positive 2 and positive 6. So the opposite of what's in there. Same deal over here on the right-hand side. Again, we've got a trinomial. Doesn't necessarily look like a trinomial, but it is. Just bear in mind you've got an x squared plus 5x, and it's missing its c value. So we've got, remember, ax squared plus bx plus c. In this case, it's missing its c value, so the c value is actually equal to 0. So those two numbers have to multiply to 0, and they have to add to positive 5. And so when you have two numbers and they multiply to 0, one of those numbers has to be 0. And if they add to 5, the other has to be positive 5. So I'm going to say that this is actually equal to x plus 0 and x plus 5 for its factored form. And then if we want to figure out what the zeros are going to be the opposite. So the zeros are actually 0 and negative 5. Okay, so the opposite of positive 0 would be negative 0 or 0. This piece here has to equal 0, and that's why I've carried it through. If we look at the last two examples, again, we've got a situation here where we have a quote-unquote tricky trinomial where the a value is something other than positive 1. So in this case, the a value is actually positive 2. So what we need to do is actually divide all of the terms that are in the equation by 2. And then again, I need to carry that 2 forward. I don't lose it. So 2x squared divided by 2 just leaves me with x squared. 8x divided by 2 leaves me with 4x. And positive 6 divided by 2 leaves me with 3. So I'm going to use my MA chart. I need two numbers that multiply to positive 3 and add to 4. Just so happens that 1 and 3 meet that criteria. So when I write out this equation in factored form, it ends up being x plus 1 times x plus 3. Okay. Now, if I want to figure out what the zeros are actually going to be negative 1 and negative 3. Okay, so again, the opposite of what's in here. Okay, so -1 plus 1 would give me 0. -3 plus 3 would give me 0. Therefore, -1 and -3 are the zeros. Okay. And then the final example here, we have to write this out as in factored form too. Again, right now it's in standard form of ax squared plus bx plus c. We actually have an a value and a c value. It's missing its b value, so let's write that in. So y is equal to x squared plus 0x, because the b value is 0, minus 16. And we've talked about how when the b value is 0, you take the positive form of the c value, in this case 16, the square root of that, the square root of the c value is then going to form your two zeros. So you're going to have -4 and +4. So in this instance, this is going to equal x minus 4 and x plus 4. And so the zeros for this last example is going to be +4 and -4. Okay, so that's just a couple of examples in terms of looking at how to get the zeros. Again, you have to convert from standard form into factored form, and then the opposite value of the coefficient that's in the binomial is what the zero is going to be.